building off of what we learned with the Pythagorean theorem, we want to come up with a way to basically go a little bit further and ask about triangles being acute or obtuse. So if they're not right, if they don't work in the Pythagorean theorem, what are they? That's really the question we're going to look at right now. All right, and if we have a right triangle, or a triangle like this, right? And we have A, B, and C, right? If it's a 90-degree angle right there, we know that the Pythagorean theorem tells us that the connection is really simple. A squared plus B squared equals C squared. But if that 90-degree angle weren't there, we need to come up with some way to take it a step further, right? And answer questions about, well, what kind of triangle is it? If it's not right, it has to be one of these two things. All right, and that's what we're going to do right now. We're going to classify triangles into the categories, whether they're acute, obtuse, or right. All right, and the basic rule is a triangle is acute if the A squared plus B squared part is bigger than the C squared. And it's obtuse if, you can write this a couple different ways. I always like to do it this way. If the C squared part is bigger than the A squared plus B squared. All right, so it kind of depends on which one's bigger, right? So let's actually look at this. All right, that's right there. That's something I would definitely copy down if I were you. So let's take a look. State if the triangle is acute, obtuse, or right. Well, first thing I'm going to do is I'm going to throw it through the converse of the Pythagorean theorem. So I'm going to go 16 squared plus 12 squared. Does that equal, this is a question now since we don't know, does that equal 22 squared? All right, so 16, that's 256, 144. 22 squared, that one escapes me. 22 squared, it's 4, I know it's 441, that's 21 squared. Let's see here. 22 squared, 484. I should have known that. All right, so the question is, does 256, does that add with 144 to get 484? And of course it does not. These numbers add to 400. So we know that they're not congruent, but furthermore, since they're not, I used the word congruent, I shouldn't have said that. Since they're not equal, we need to take a little step further here and really answer this question. How do they relate to one another? All right, the C squared term is bigger than the sum of A squared and B squared. So this is going to be an obtuse triangle. In other words, this angle right in here, that angle right in there is an obtuse angle. All right, number 2. Same question. We're going to throw it through the Pythagorean theorem converse. We're going to see if it works in the Pythagorean theorem. When we do that, we use a question mark. And we go to our calculators here. 36 times 36 is 1296. 49 times itself is 2401. Does that equal 3600? Well, I can tell right now that it definitely does not, but more importantly, I want to figure out what it does equal. Right, because we know it's not a right triangle, but we want to think about what kind of triangle it is. These added together, you get 3697. Clearly that those are not equal to each other. Furthermore, now we're going to answer the question, well, what kind of triangle is it? And if the A squared plus B squared part is bigger than the C squared, that's when we're talking about an acute triangle. So this angle in question, it's not 90 degrees, and furthermore, it's acute, which makes the whole triangle acute. Last one, number 3. question says state if the triangle is acute, obtuse, or right. So we're going to throw those three sides through the Pythagorean Theorem. Clear this out. 80 squared, I'm going to do this all at once, one step, plus 84 squared, that's 13,456. And we're going to see if that is equal to 116 squared. It is. So this is a right triangle. Alright, which means this angle is 90 degrees. Great.